We're going to be talking about monomials and polynomials in this lesson. And we are going to, first off, let's talk about a monomial. A monomial is a number or variable that is a product of numbers and variables. So in other words, it could be something as simple as just 3, or it could be something like x, or it could be something like negative 7x squared y, or we could have 2x. So it doesn't just have to be a single one term. The big thing is there won't be addition or subtraction separating any of the variables in it. It's only multiplication that's separating them. So before we can really work with these, we need to talk about what are the exponent rules, because we need them to help us simplify down our expression. So when we talk about the product rule says if I have two of the same base, we can add the exponents and it gives us a new answer. So we have x as the base for both of these. So we are raising it to the second and the 7th power, so that means we have x to the 9th. So here, if we have a number raised to a power, a number raised to a power, we can take these two powers and multiply them, and then that will give us our new answer. So our x is to the 14th power. So again, if we have the same base, and we have to have the same base before this works, we can take our two exponents and subtract them. And so we have x to the 7 minus 2, which is 5. Anytime you have a negative exponent, if you move it to the denominator, it becomes positive. So we have a negative 2 on the exponent. So x to the second, as long as I have it in the denominator, that changes it to positive. And then the zero exponent rule says that anything raised to the 0 power is equal to 1. So it doesn't matter what I put in the parentheses. If I raise it to the 0 power, I get 1. The exception to that rule is 0 to the 0 power doesn't equal 1. It does not exist. So now let's look at doing a few of these problems. So let's start off with a little bit more basic. So on this first problem, I have 5x squared times negative 7x to the 6th. That's 5 times negative 7, because I can regroup it. The only thing I have in this problem is multiplication, so I can regroup my multiplication together, where the variables are together and the coefficients are together. So negative 5 times negative 7 is a negative 35. We would take these two exponents and we will add them, giving us x to the 8th. So in this next problem, the first thing I need to do is take care of this exponent out here. So I'm going to distribute it through to every single item. So that's going to give me negative 2 raised to the 2nd power. It's going to give me xa cubed raised to the 2nd power. It's going to give me b raised to the 2nd power. And now I'm just going to bring down what I had originally, 8ab to the 9th. Negative 2 times negative 2 is a positive 4. So I have 4. I'm going to take these two, I'm going to multiply them. So a to the 6th, b to the 2nd, times 8ab to the 9th. I'm going to regroup, move my 4, and my 8 is going to come over here and join it. And then I'm going to take my a to the 6th and it's going to get joined by the a to the first, b to the second. It's going to join the b to the ninth. 4 times 8 is 32. A to the, this time we're going to do add, so 6 plus 1 is 7. B to the 9 plus 2, which is 11th. So that's my answer for each of those. So let's look at number 3. The first thing I need to do at number 3 is I need to take and simplify this. So we have 54 over 3. M, we're going to subtract those. So 6 minus 2, n to the 4 minus 1, minus 10 m to the 4th, n cubed. So 54 divided by 3 is 18. M to the 4th, n to the 3rd, minus 10 m to the 4th, n cubed. Since these match, then I can combine. So that's going to give me 8 m to the 4th, n cubed as my answer. Let's take number 4. All we have is two things being multiplied, so let's go ahead and rearrange it. So we have 2 times 10 times k to the 4th times k to the negative 7. So I'm going to take these, I'm going to add them. And so that gives me k to the negative 3rd. And I have the 20 that's being multiplied in front of it. So this k to the negative 3 has to go to the denominator. So we end up with 20 divided by k cubed. And that's your answer. So now let's look at number 5. I want you to look ahead and see, what do you think we could do first? You should have said we can take and distribute that one exponent through to everything in that parenthesis. So we're going to take that second power and we're going to distribute it to both pieces of the variables and the fraction. So I have 2/3 raised to the second power. I'm going to have r squared raised to the second power, and I'm going to have s to the 7th raised to the second power. And the rest of it just comes down. And so I have 1/6 r cubed s. So when I have 2 divided by 3 times 2 divided by 3, that gives me 4 divided by 9. So 4/9. I'm going to multiply my exponents as I'm raising a power to a power. So r to the 4th. I'm going to multiply my exponents because I have s to the 14th times 1/6 r cubed s. Now I'm going to rearrange. 4/9 times 1/6 is equal to r, or times r to the 4th times r cubed times, now we have the s's, so we have s to the 14th and s to the 1st. So when we multiply this, we get 4 divided by 54. R, we're going to take our exponents and we're going to add them, so r to the 7th. We're going to take our exponents, we're going to add them, so s to the 15th. Now, 4 over 54 are both divisible by 2, leaving us 2 and 27. And so we have 2/27 r to the 7th, s to the 15th. And that's your answer. So on number 6, the first step you would do is simplify inside the parentheses. So 14 divided by 7 is 2. We're going to take our exponents and we're going to subtract them because we have the same base. So we have 2w to the 9th, all to the negative 1 power. So that means I'm going to take this entire thing and I'm going to move it to the denominator. So I have 2 times w to the 9th underneath that 1. So number 7, we need to simplify each part. I want you to try to think about how you could do it and work it out in your paper. So you should have seen that we could take and divide both 15 and 24 by 3, giving us 5 and 8. So I have 5/8 x, and I'm going to take these two and I'm going to subtract it. The numerator goes first, so 10 minus 12 y, 4 minus 3. So I have 5/8 times x to the negative 2, y to the first. So this negative 2 means it needs to go to the denominator, so it's going to go ahead and join the 8, and that positive 1 means it's going to go to the numerator. So I end up with 5y divided by 8x squared. Let's look at number 8. We need to simplify inside the parentheses. So that gives us c to the 1 minus 2 raised to the 4th power. So that's c to the negative 1 raised to the 4th power, which is c to the negative 4. Now let's talk about what's going on in the rest of it. So in this next part, I have that negative 4 that can go to both pieces. So that means I have negative 3 to the 4th, and I have c to the 4th. So if I take that negative 3 times 3, negative 3 gives me a positive 9. So I'm going to take that 9 times the negative 3. That gives me a negative 27. I take that negative 27 times 3. A negative 3 gives me a positive 81. So that's 81 c to the 4th. And so we'll go ahead and write it down on this next line. Now that 81 just going to come to the front. I have c to the negative 4 plus c to the 4 because we're going to add these exponents. So that's 81 c to the 0 power. So c to the 0 power becomes 1. And so I have 81 times 1, which is 81. And that is my only part of the answer that I have. So looking at number 9, we have the answer. We've got to come back to the problem. So this is the answer. We want to come up with a problem that will create it. And this needs to give us a quotient, which means divide. And so let's think about what two things can divide and equal negative 3. Well, I could do negative 15 and positive 5. So let's go ahead and do that. Negative 15, positive 5. Well, I want to think about what things could divide to give me n squared. So how can I do my n's? This one would need to be larger by 2. So n to the fourth and n squared, the larger needs to be in the top, n to the fourth, n squared. Now let's take our m's. I need 1 over m as my result. So that means that I need to have the larger one second. And so I'm going to take m to the third, m to the fourth. If I subtract those, that's going to give me -1, which is here. So m to the third, m to the fourth. That is one example of a problem that we could create that would give us this solution. There are many other ones you could have done. This is just one possible solution. So now, a polynomial is a sum or difference of many monomials, like this. And so the highest exponent of the polynomial is called its degree, and that's its power, and we'll call it by what it is. In the standard form, we always write the exponents in descending order. So if we look here, we've got to come up with what is my highest power. So my highest power of this first one is to the fifth power. So that's the one I write first. That goes away. Its sign goes with it. So the next one we have is to the third power. So the whole thing comes with it. So -3k cubed. That's gone. Now the next one is squared. Plus 1/4 k squared. That's gone. Now plus 8k and then -1. And that's your answer. We will write it in standard form with the exponents decreasing. So now let's look again. We need to look for we need to go for the alphabet, and we're going to try to find what is the highest power of A, because you always go in alphabetical order. So 4a cubed, its sign goes with it, so it's positive. That's gone. Now my next highest power is a squared. So plus 18a squared b squared. So that's gone. Plus 7ab, that's gone. Minus b squared. And so I've got everything listed. We're done. So again, my highest power on x is x cubed. So 9x cubed y. Now that's gone. A minus 2, or minus x squared. That's gone. Then I go down to here to the 1. And so we have plus 5xy. So that's gone. Now I'm left with just these two things. So we go to the next highest power, which is y. Y to the fourth plus 2. That's it in standard form. Okay, so now let's talk about how would you classify a polynomial by what its degree is. And the degree is like me saying, what is its power? What power are we at? And so we're going to go with the largest power, and that gives us our degree. Now, number of terms. These are separated by addition or subtraction. And so we're going to go with monomial, binomial, trinomial, and polynomial. So now, let's look here. I have two terms. My highest power is 1. So my degree is 1. So I have a linear binomial. So let's look at this next one. I have 1, 2, 3 terms. So 3 terms. And my highest degree is 5. So degree of 5 is quint. So I forgot my M. Quintic. And I have 3 terms, so it's trinomial. So I have just 1 term and no variable. And so that means my power is 0. So that gives me a constant monomial. So looking at 16, we have 1, 2, 3, 4. 4 terms. My highest power is 3. So that means I have a cubic polynomial. I have 1, 2, 3 terms. My highest power is 2. So I have a quadratic trinomial. I have 1 term. My power is 4. So I have a quartic monomial. So for the next 2, you're actually going to have to create your own. So if I want a cubic binomial, that means I have 2 terms and third power is my highest. So I'm going to do something with x to the 3rd power, but I need to either add or subtract something else. So I'm going to add 8. That is a cubic binomial. I could have also done something like 3x to the 3rd minus 7x squared. That is also a cubic binomial. So a linear monomial is anything that has 1 term and x has a power of 1. So something like 3x.